Thank you very much. And also many thanks to the organization committee for the opportunity to talk here about a recently published paper titled "The Test-retest Reliability of Prefrontal tDCS Effect in Functional MRI Connectivity." So as the title already suggests, we are focusing on the brain at rest and how the resting state connectivity changes from baseline to after tDCS. Thereby, we are mainly concentrating on prefrontal stimulation because we are focusing on translational research, and the DLPFC is a major target in clinical application. There's previous studies showing that prefrontal tDCS may be effective in modulating resting state connectivity. So, for example, one study by our group found that nodal tDCS over the left DLPFC led to an increase in functional connectivity within the frontal parietal network as compared to sham. At the same time, the test-retest reliability of tDCS has recently been questioned, except one study here showing good reliability values. All other studies investigating this topic found low ICC intraclass correlations for tDCS effects. However, this has been only investigated for tDCS applied over the motor cortex, so that implies that the test-retest reliability of tDCS has only been characterized for modulation of motor evoked potentials, and therefore the aim of our study was to evaluate the test-retest characteristics of prefrontal tDCS-induced modulations in resting state connectivity. So for this purpose, we recruited 20 participants, and we randomly split them up in two groups, one active and one sham group, and then all our participants underwent 3 testing sessions with at least 1 week in between sessions to avoid any carryover effects. At each testing session, participants received the very same protocol depending on the group they belonged to. So there was always a baseline resting state scan for 10 minutes, followed by stimulation of the DLPFC for 20 minutes, with the anode placed over F3 and the cathode placed over F4 at an intensity of 2 milliampere. And then that was followed by a so-called post-tDCS resting state scan, again for 10 minutes. Resting state connectivity was then determined with 2 different approaches, one region of interest approach, the ROI, and one independent component analysis, ICA approach. For the region of interest approach, we selected prefrontal ROIs according to studies modeling the current density and the current distribution for our electrode arrangements, and then based on these computational models, we drew 3 different hemispheric specific ROIs. In a second approach, we identified resting state networks using the ICA, and again here our network selection followed previous findings and resulted in 4 different networks. The left and right frontoparietal network shown in A and B, and the anterior and posterior default mode network shown in C and D. Resting state connectivity within these ROIs and individual independent components were then determined separately for each measure, so for the baseline and post-tDCS scans, separately for each testing session, and separately for each group. Finally, we then calculated voxel-wise intraclass correlations between those maps, so between the baseline resting state maps and between the post-tDCS maps, and we did that across all 3 testing sessions. For presentation of results, I now first show average ICC values, which were generated by median calculation across voxels. And if we look at those median ICC, we identified low to moderate ICC values at baseline level, independent of the group, for the ROI approach. However, for post-tDCS, these ICCs clearly dropped behind baseline in the active group, such that they were only classified as poor here. But this was not present in the sham group. Here, the ICC value stayed at baseline level. Yes. A different pattern emerged for the ICA-based approach. Here we found low test-retest reliability values for both the baseline and the post-tDCS measures independent of the group. So, the just described observation can now be further illustrated in histograms, which now show the voxel-wise ICCs. And if we look at the Roy-derived ICCs, we see that in the sham group, the ICC frequency distribution of the baseline and the post-tDCS measure largely overlap, pointing towards a close match in ICC levels for those for this group. By contrast, in the active group, the post-tDCS measures were shifted towards lower values, that we have two different distributions shown here. Again, this did not apply to the ICA-based ICCs. Here, the histograms largely overlapped, independent of the group. If we now relate our findings to previous literature, we see that there's a discrepancy between previously reported moderate to good reliability of resting state connectivity and low to moderate reliability of our baseline resting state measures, and we think that that discrepancy mainly arises from our small sample size. The additionally low test-retest reliability of baselines in the ICA-based approach may arise from the large spatial extent of these networks and also from network selection, because we mainly focused on resting state networks that are associated with higher order cognitive functions. And this low baseline reliability within the ICA approach may have masked any clear difference between the baseline and the post-tDCS measures. However, within the Roy approach, we found a clear drop in reliability from baseline to post-tDCS in the active, but not in the sham group, and we think that this may argue for additional variability as induced by active tDCS. So overall, our assumptions support the notion, our findings support the notion that active tDCS modulates resting state connectivity. However, this may happen with variable and divergent effects. This assumption of highly variable tDCS effects at intra-individual level would be consistent then with available data showing low test-retest reliability and high intra-individual variability of tDCS effects on modulations in motor-evoked potentials. So before I finish, I would like to thank my group in Munich with special thanks to Frank Pattberg, Daniel Keser, Konstantin Helbig and Lena Koch. And I would also like to point out that there's a poster displayed this afternoon if you're interested in further discussion. And yeah, I would like to thank you for your attention, and I would like to draw your attention to the nice landscape of Bavaria. So we also have very nice hiking trails, and if you want to visit them, there's a conference taking place in Munich this autumn. So thank you very much.
Thanks very much for that talk and questions. I'll go to the floor. We have about 2 minutes.
Hello, thank you very much for that. I'm just curious as to, okay, so you've discovered that the application of this electrical current stimulation is modulating activity in functional brain networks, presumably. But there's all of this individual variability. Do you have any thoughts on what the next steps are for if we wanted to make things more consistent, or how we're going to go about actually making it so that we can use this technology in a reliable way?
Yes. So first of all, I think we have to replicate those results within a larger sample. And then another step may be that we have to move away from group analysis or something like that, and we really have to go to the individual level and look at individual responses. So, and try to separate non-responders from responders, and yeah, try to move on this way.
Okay, thank you.
Thank you.
Hi. Hello, do you hear me?
Yeah.
I was wondering how much did you control for the state of participants, because the default mode network is very dynamic.
Yeah.
And of course, tDCS or any other stimulation depends on the state or the task performance. So if you are, for instance, in a self-reflectory state or some different state, probably tDCS will also have a different effect.
Yeah, that's true. So first of all, we tried to keep the daytime of measurement constant across within participants. And second of all, we had some questionnaires controlling for emotional states and something like that. And we couldn't find any differences here between the measurements.
Like mood,
Yeah.
Okay.
So we had the PANAS questionnaire, and you also, yes, recorded the BDE just to see whether there's any depressive symptoms changing over time.
Thank you.
Thank you.